In 2025, getting your hands on a powerful AI model is the easy part. The real friction has moved down the pipeline. The bottleneck you face now is choosing the right system architecture to actually run those models. Mastering a new AI framework is a massive commitment. It takes hundreds of hours to learn the quirks of a specific ecosystem. If you choose the wrong one, you end up with a mountain of technical debt that can paralyze a project before it ever ships. A lot of developers fall into the SDK illusion, the belief that building an AI app simply means sending a ping to an API. This diagram shows how that illusion breaks down. If you follow path A, using a direct provider API works perfectly for a basic text prompt. You send a question, you get an answer. But if you look at path B, trying to build a complex, multi-step application this way hits a wall. Real-world AI applications require a lot more infrastructure. You have to handle document loading, manage autonomous agents, and store data in a vector database, a specialized storage system holding mathematical representations of data, allowing the AI to quickly find similar concepts. A simple API wrapper won't build that for you. This is where AI frameworks come in. They provide a higher level of abstraction, managing all these complex components so you don't have to code them from scratch or lock yourself into a single provider's ecosystem. To avoid building a brittle application, you need to map the top AI tools to their exact use cases. We'll break down the frameworks for deep learning, LLM orchestration, and edge deployment. Relying solely on a basic SDK restricts what you can build. If you want an application that scales, handles custom data, or deploys locally, integrating a dedicated framework is mandatory. We start with the core ML heavyweights.
These are the foundational environments you use when you need to train deep learning models entirely from the ground up. This comparison matrix outlines the two dominant players, starting with PyTorch. It uses dynamic computational graphs, cleanly integrating with Python. Because of this, PyTorch is the gold standard for academic research and rapid prototyping. But that flexibility comes with a cost. Scaling a PyTorch prototype for enterprise production requires significant manual engineering effort. On the other side is TensorFlow, built explicitly for robust deployment across servers and mobile devices. If your goal is to push a model to millions of users, TensorFlow provides massive stability and scalability. The trade-off is friction. It has a steep learning curve and requires intense computational resources. Choosing between these two heavyweights comes down to a specific question. Does your project prioritize the speed of mathematical discovery or the stability of a massive commercial deployment? Most developers today aren't training models from scratch. They are building applications on top of pre-trained large language models, which requires an entirely different toolset. To do that, you use modular orchestrators like LangChain and LangGraph. These act as the connective tissue, allowing you to string together complex AI behaviors. Look at the first row of our orchestrator matrix. These tools let you build autonomous agents that retain memory of past conversations and call APIs to fetch real-time data for advanced workflows. The catch with these open-source tools is the abstraction layer itself. It can overcomplicate simple tasks, and because the community moves fast, you will constantly update your code for breaking changes. The alternative is to rely on proprietary cloud agent SDKs, like the Microsoft Agent Framework or Google's ADK. These cloud-native tools offer incredibly easy setup, but they trap your application. You agreed to strict vendor lock-in, tying your infrastructure entirely to their fixed cloud pricing. In GenAI development, prioritizing extreme ease of use usually means trading away your independence and your ability to swap out models when a better, cheaper option hits the market. That brings us to the final frontier, moving AI out of the cloud entirely and deploying it directly onto local hardware, known as edge computing. Running AI models locally requires severe optimization. Tools like the Intel OpenVINO toolkit exist specifically to compress and quantize AI models so they can fit on a personal device. Quantization is a technical process that reduces the precision of a model's numbers, shrinking its file size and memory usage with minimal loss in accuracy. This matrix maps out the edge environment. OpenVINO manages the heavy lifting across a machine's CPU,
GPU, and neural processing units. This allows you to achieve high-performance, power-efficient inferencing right on the local laptop. The downside is that this approach requires specific hardware configurations, like a modern AI PC, and it forces you to add a dedicated optimization step to your software pipeline. If you want to bypass local software installations entirely, you can look at the Web Neural Network API, or WebNN. This allows AI models to run directly within a user's web browser, while still accessing the local machine's hardware for near-native performance.
But WebNN has a severe limitation right now. It is highly accessible, but it remains an experimental feature undergoing community testing. It lacks the mature, production-ready stability of traditional deployments. Escaping exorbitant cloud computing costs and guaranteeing user privacy means you have to master hardware layer optimization, taking on the burden of local configuration yourself. This quadrant chart gives us our final actionable blueprint. By plotting the effort required to learn a framework against the scale at which it deploys, we can map exact tools to your specific situation. For beginners and data analysts, prioritize immediate understanding over deep complexity. Stick to high-level APIs like Keras or scikit-learn to build functional models quickly. If you're a researcher inventing new architectures, prioritize absolute mathematical control using PyTorch or JAX. For enterprise builders, prioritize model-agnostic orchestration. Adopt LangChain or Llama Index to build complex workflows, avoiding proprietary cloud lock-in. And for developers targeting local hardware to save on cloud costs, prioritize local optimization. You will need to learn tools like Intel OpenVINO, WebNN, or Microsoft Foundry to get models running efficiently on end-user devices. Stop looking for an objective best AI framework. The technology is too specialized. Define your target deployment environment first, and let that environment dictate your technology stack.